Hello everyone. Uh, Today we will discuss the problem based on the cantilever beam, and we'll draw the shear force diagram and bending moment diagram of this cantilever beam having this 2-point load and one couple in this beam. So this is the cantilever beam having this point load 10 kilonewton and then the 5 kilonewton. Then there is one couple from here to this couple. The distance is suppose 3 meter, it's 2 meter, and then from here to here this 2 meter. So I'm giving name this A, this point is B, this point is C point, and here it is D point. So this is the problem related to the cantilever beam having 2-point load on a span with one couple. So how to solve this problem? Simply, to solve the problem, first we draw the free body diagram as we have discussed in an earlier lecture. So if you draw the free body diagram, so this is the free body diagram since it is cantilever beam and this is the fixed end. So here the reaction RD will come, then the horizontal reaction RDX will come, and the moment will come to counterbalance this force. So moment I'm giving name this MR. So this is the 10 kilonewton, this point A, and this is the point B where the 5 kilonewton is there, force, then couple is there, and this couple is this 5 kilonewton meter. Couple is 5 kilonewton meter. So this is the 5 kilonewton meter couple is there. This is the point C and this is the point D. So this is the free body diagram of this problem, and then the next step is equation of equilibrium to find out the support reaction. So we use this equation of equilibrium to find out the support reaction. So first calculate the summation of fx equal to 0. So here only rdx is there, that is nothing but equal to 0 because no other horizontal force is there. Then similarly the summation of fy equal to 0, so only the vertical force will consider. So summation of fy equal to 0. So here as per our assumptions that if you move from right to left, I move from right to left this side, if our movement is like this, so downward force will consider the positive, so positive 10 kilonewton will be there. Similarly this positive 5 will be there, and then because this is the summation of y, only the vertical forces we will consider, no moment will consider here. So this 5 kilonewton meter is nothing but a couple, it's nothing but a moment, so we will not consider this as a vertical force. So this plus 5 and this plus 10, so this is the downward force we are taking positive, and here RD is there, only vertical force which is upward, so we are taking this RD as a negative and equal to 0. So RD we can write this 15 kilonewton. So RD value is 15 kilonewton. So now to find out this moment value, we can also take moment equal to 0. So moment about D we can take. So here when we are taking the moment, this clockwise we are taking positive, anti-clockwise we are taking negative. So moment is nothing but the force into perpendicular distance. So 10, moment is clockwise, so 10 into the total distance, which is nothing but here to here 3 meter, here to here 2 meter, and here to here again 2 meters. So total is 7 meters. So 10 into 7, this clockwise positive, then 5 clockwise into 3 and 2, 5 meter, and here in this cantilever beam, since the counter this rotation is there which support this beam to go downward, because these vertical forces try to bend this beam downward side, so this counter this moment will try to resist it, so that because its moment is anti-clockwise, so we are taking here minus mr equal to 0 because moment is there. So this mr will be, so if you calculate this, so 70 plus 25, okay, one couple is also there, that is a 5 kilonewton couple is there having this clockwise rotation, so couple will be considered here in this moment, so plus 5 will be there, so that plus 5 is nothing but the couple, so here the plus 5 is there, so mr will be 70, 25 plus 30 is nothing but 100 kilonewton. So this is the moment value. Because one couple was there, it was missed, so we have taken this couple as a plus 5 because the clockwise moment is there. So this is the 5 plus 5 minus mr. Now how to calculate the shear force diagram calculation. To calculate the shear force diagram, this particular problem, so here at A we can see that at particular A the shear force diagram only take the vertical forces, because shear force is nothing but summation of all the vertical forces. So at A here we can see that 10 kilonewton is there, so at A shear force is 10 kilonewton, that I can write this is nothing but shear force, or at A shear force is 10 kilonewton, we can write like this. The next at B, here you can see that from A to B, because no other force is there, so only the 10 kilonewton is constant up to B, and at particular B 5 Newton is there. So just before, we can say that just before B it's a 10 kilonewton only, and at B the shear force is, since because it's a downward, for the shear force downward we are taking as a positive, so the 10 is positive and plus 5 is also there, so that will be 15 kilonewton. So at B here it's a 15 kilonewton, and at A it's a 0, at A it's a 10 kilonewton, not 0, and at C, just before C, if you see just before C, shear force is here, the C is there, C point is there, so whatever the value is there, that is 15 kilonewton, will be constant up to just before the C, and at C because this 5 kilonewton moment is there, but since it is a shear force diagram, so moment will not be considered, only the vertical forces will consider, so this will be constant just before C, and after C also it will be constant. So this is the 15 kilonewton, and at C the shear force will be 15 kilonewton, because only we are taking in the shear force diagram the vertical forces, we are not taking the moment, we are not considering the moment while calculation the shear force diagram. This is very important. Now at D shear force will be, because here A, when we are moving A to B it's a 10, then B it becomes a 15, and it's constantly moving because no other vertical forces is there up to RD, up to D. So only the 15 will be there, which is positive because downward, and at B RD is there, at D RD is there, which is upward. So RD we can write here 15 minus RD value is nothing but 15 kilonewton here. This is the 15 kilonewton. So we can write an upward force is there, so direction is negative and equal to 0. So at D the shear force will be 0. Now based on that we can draw the shear force diagram. So here I can draw the shear force diagram. This is the positive shear force and this is the negative shear force. This is the X. Now we can, based on this calculation, 8A, it's a 10, so I am just giving name 8A. This is the A, 10 kilonewton, which is positive. So I am just putting the, because it's a point load, so vertical line will be there. So this is nothing but 10 kilonewton. And then at B it's 15 kilonewton. Now at B, this is the B. So because no other forces will be there, so just before B it's a 10 kilonewton constant will be there, but at B it's another 5 kilonewton is there, means total 15 kilonewton is there at B. Now at C, this is the point C, is going constant. Here also 15 kilonewton is there, and just before D also it's a 15 kilonewton, and at D it's 0. So at D here equal to 0. So this is at D. At A it's a 10 kilonewton because of this point load, so vertical line will be there. Then A to B there is a no force, so constant 10 kilonewton will be there. Then at B it's a 15 kilonewton positive, so it will go positive 15 kilonewton top. Then the C point, only the couple is there, which we are not considering to draw the shear force diagram, only the vertical force we consider. So here constant line will be there, this total constant line will be there just before the D, it's a 15 kilonewton, and at D again it comes back to 0. So this is the shear force diagram for this particular problem, positive shear force diagram. This is the shear force diagram. Now similarly bending moment calculation, if you calculate here the bending moment diagram calculation, here you can see that in this diagram. So at A, so yeah, just I'm drawing a line. So at A bending moment is at A, so here x equal to 0, no other forces is there, so bending moment will be 0 here only. And if you move from A to B, so at B bending moment will be, so bending moment will be 10 into this 2, so 10 into 2, this will be the bending moment. But for the sign convention of this bending moment, drawing the bending moment, this type of appearance is there because this is cantilever beam, and this cantilever beam is try to rotating by this 10 kilonewton downward side, this side like this, it try to rotate. So this beam will be bent like this. So this is called the negative, we are taking negative. This type of rotation will take negative when we are moving right to left. So here 10 kilonewton rotate in this like this side, so it will, we are taking minus 10, so the bending moment at B minus 20 kilonewton. Then if you are moving from A to B, it's minus 20 kilonewton. Then B to C, just before C, if you give, so just before C bending moment minus 10 into this 4, because from just before B it's a 10 into 4, just before C it's a 10 into 4, then minus 5 into 2, so it will be 40 minus 10, that is nothing but minus 50 kilonewton. Then 8C bending moment will be, so same, this 5 kilonewton will come into the picture because moment is there, so that is nothing but minus 50 and minus 5, that is nothing but minus 55 kilonewton. 8D bending moment will be, this bending moment will be 10, which is minus, so 3 and 4 7 meter total here, so total 7 meter, 10 into 7 meter, 3 and 4 7 meter, minus this 5 into 5 meter, then minus, because this try to rotate this side, bend, so minus 5, and because anti-clockwise it is moving, which try to resist the motion of this bending, so we are taking this as a positive, so that is positive MR equal to 0. So this is minus 70 minus 25 minus 5 plus this MR value is here, we are taking this 100 kilonewton, so we are putting this 100, then equal to this minus 70 minus 25 minus 5 is nothing but minus 100, 100 equal to 0. So at D bending moment is 0, at C bending moment is minus 55 kilonewton, just before C it's a minus 50 kilonewton, and at B it's a minus 20 kilonewton, and at A it's a 0. So now for this we can draw the bending moment diagram. So this is the value at A, bending moment is 0, at B it's minus 20 kilonewton, and just before C minus 50 kilonewton, and at C it's a 55 minus 55 kilonewton, at D it's a 0. So this is the actually the bending, the shear force diagram, and we can plot here the bending moment diagram for this particular problem. So this is the C point, this is B point, this is A point. Here we can see that at A here the bending moment is 0, and at B it's minus 20 kilonewton. So I can draw, suppose this is the, this linear incline, this is inclined line will be there, linear inclined line, because a point load. So here I can see it's a 20 kilonewton, which is in the negative side at particular B. Now from B just before C, or we can say particular just before C, it's a 50 kilonewton, which is negative. So just I can move this inclined line again for this 50 kilonewton. Suppose this is the 50 kilonewton. Here this is particularly the 50 kilonewton value is there, and at particular C we have seen, because couple is there, so suddenly the value is changed and it is 55 kilonewton at particular C. And from this C, D point if we draw, so 0 again, so here to here this inclined line we can join, and the inclined line will be like this. This is suppose inclined line. Okay, so this is the diagram for this particular problem, the bending moment diagram. Here you can draw like this. You can draw, this is the negative side, so bending moment is there. So at A it's a 0, at B it's a 20 kilonewton, at a C, this is the C point, it's a 50 kilonewton, and suddenly C, because of couple, it changed and becomes the 55 kilonewton, and at D it's a 0 again. So this is the bending moment diagram for this particular problem. Likewise, you can calculate here, this is nothing but the shear force diagram, and this is the bending moment diagram for this particular problem. So like this, you have to consider all the sign conventions, and you can able to solve the problem related to all the shear force and bending moment diagram. So till then, thank you.